All right, so let's take a look at this. Oh, there we go. All right, before we can do this, we need to know the force. Okay, so, oh, I did 77.5. That's why I thought that number came out funny. I don't know why I put 77.5, because I was thinking 2.5 million. Okay, so F equals mg, that's the weight. We're at 9.8 meters per second squared, and m is the mass. So mg is 77 times 755 newtons. So he lifted it 755 newtons times 2.5 meters, 1887.5 joules. What did I come up with? 1898? I said 1900 joules. That's close enough. Now, I've got a question for you. Now, here's what I want you to think about real quick. Okay, he overcame gravity to lift that 2.5 meters. We're assuming he lifted it at a constant speed. Okay, I mean, there was a point there where it went from 0 to a certain speed and stuff, like where there's a kind of a burst, an impulse is what we call it, to get it going. But then it kind of probably went up at a constant speed. How much work did gravity do? So in this problem, and I'm going to keep it with the 7.5 meters, I want you to take a look, because we don't talk about this in the slide, so you need to pay attention here. Okay? How much work did gravity do? Well, let's take a look. Here real quick. So in weightlifting, in the weightlifting problem, how much work did gravity do? Okay, so the force went up. Now, first of all, did gravity do any work? Notice the force went up of, well, in our case, we had I'm going to go back to the 77.5. So we had 77.5 times 9.8. 750. So in my because I wrote it down wrong, we got 760 newtons. That's the vector going up. Which way is gravity pointing? Down. Okay. Gravity is actually, here's the gravity vector, but the displacement vector that we pushed up is going up 2.5. Are they parallel? Yes, they are. It's a fancy physics term we call anti-parallel. And so since the work done by gravity would be negative 760 newtons, because it's going down this way, all right, because here's the force, because for every action equal and opposite reaction. So anti-parallel. So it'd be negative 760 newtons times the positive 2.5 that it went up, and it did negative work of minus 1878.75 joules, or almost negative 1900 joules work. So the net work done in the whole system, 0. In other words, we didn't add any energy to the universe, but he did not add any energy to the universe by lifting this up. That's a subtle physics thing. I mean, I could have just taught you, hey, you just lift this up, whatever. But there's the difference, okay, between just doing a math problem and actually learning the physics. The net work that's done here is, so how much energy was added to the universe? None. The net work is equal to 0. All right, that is a cool concept, by the way, that I've never taught before. You guys are the first ones to get it. I guess I'm in a mood with these mini things. Okay, now we're going to look at this rock climbing. You can look at this David Ossman. He passed away, I think, in 2010 in a rock climbing accident. So go ahead and watch that slide. It's something else. We'll take a look at his thing in the next video.